Hello and welcome to the Tech Crazy channel. In this video, I am going to explain you about the limits, fits and tolerances. So I am also going to explain you about the limit gauges. First of all, let us see the terminology of limits, fits and tolerances, means the different terms which we are going to see in this chapter. First one is shaft. Shaft means it is the term serves for specification of the all of outer elements of the part, including those which don't have the cylindrical shape. Means it is the any part. This term what it serves is for specification of all outer elements. So means all outer dimensions, outer elements, so whatever it is, so that term, that will be, we are going to term them as a shaft. So you can see here, so this is a circular one and this is a rectangular one. So मतलब shaft means it is circular भी हो सकता है, so rectangle भी हो सकता है. So any outer dimensions, so that is called the shaft. And next is hole. So it is the term used for specification of all inner elements regardless of the shape. So whatever the inner elements, so they will be termed as the hole. So here you can see, so this is the circular hole you can see, and this is the rectangular one. Means irrespective of the shape, कौन सा भी shape हो सकता है, it may be of any shape. So here I have just shown the two shapes, circular one and rectangular one. So it may be some other shapes. Hole means it is a used for specification of all inner elements regardless of the shape. Okay, so they are called the, that is called the hole. So next is basic size. So basic size means it is the size of the part in relation to which all limits of variations are determined. Suppose let us say, so here it is a dimension of any one part, that is 10 plus or minus 0.1. So here you can say, so 10 is the basic size. So with respect to this, so here it is tolerance is given plus 0.1 and minus 0.1. मतलब dimension कितना हो सकता है, 10 plus 1, sorry 10 plus 0.1 and minimum is 10 minus 0.1. 10 plus 0.1 means it is 10 plus 0.1 means it is 10.1 and 10 minus 0.1 means it is 9.9. Means so this dimensions are defined with respect to the this dimension. So this dimension 10 is called the basic size. So basic size means it is the size of the part in relation to which all limits of variations, so these are the variations, plus 0.1 and minus 0.1, that is the variation are determined. Next is deviation. So deviation means it is the algebraic difference between limits of this, between limit of size and the corresponding basic size. So you can see here, so here it is 10 plus or minus 0.1. Take example of one dimension of the object, let us say it is a 10 plus or minus 0.1. Means here upper deviation is, so upper deviation is plus 0.1 and lower deviation is minus 0.1. मीन्स ऊपर के साइड में कितना अलाउड है चेंजेस एंड नीचे के साइड में कितना अलाउड है विथ रिस्पेक्ट टू बेसिक साइज. So that is called the deviation. So upper deviation is, so deviation are again classified into two types, upper deviation and lower deviation. So here you can see, so here it is upper deviation is plus 0.1 and lower deviation is minus 0.1. Suppose here you can see, so in this case 10 minus 0.1 minus 0.2 means upper deviation is minus 0.1 and lower deviation is minus 0.2. So next is limits. Limits means the maximum and minimum permissible sizes within which the actual size of the component lies are called the limits. So example, if you see, so here it is the dimension of the part, so 10 plus or minus 0.1. So here maximum limit is 10 plus 0.1. 10 plus 0.1 is means maximum limit is 10.1 and minimum limit is 10 minus 0.1. 10 minus 0.1 means it is minimum limit is 9.9, means 10.1 and 9.9 are called the limits. 10.1 is the maximum limit and 9.9 is the minimum limit, means the whatever the dimension of the part, so that should be between these two limits, these two dimensions. Next is tolerance. Tolerance means it is the difference between upper limit and lower limit of the dimension. So it can also be defined as the permissible variation in dimension. So in the previous slide we have seen that, so limits 10.1 and 9.9. So whatever that this difference 10.1 minus 9.9 means it is 0.2, means tolerance is 0.2. Okay, tolerance means it is the difference between upper limit and lower limit of the dimension. It can also be defined as the permissible variation in dimension. So 0.2 in the previous slide, so it is plus in above side it is 0.1 and below side is 0.1, means it is total is 0.2 variation. 0.2 variation is allowed. So that's why, so tolerance can also be defined as, it can also be defined as permissible variation in dimension. So tolerance are again classified into unilateral and bilateral. So we shall see in detail in the next slide about the tolerance. Next is allowance. Allowance means it is the intentional difference between the hole dimensions and shaft dimension of the any type of fit. Allowance means it is the intentional difference between the hole dimension and shaft dimension for any type of fit. Means देखो, suppose if you take example, so let us say this is the dimension of the hole and this is the dimension of the shaft. So dimension of the hole is 10 plus 0.1 minus 0, means upper limit is 10.1 and lower limit is 10. So next shaft dimension is 10 minus 0.1 minus 0.2, means it is upper limit is 9.9 and lower limit is 9.8. So here you can see, so there is always, suppose देखो, means minimum clearance between this and this shaft and hole is 0.1. So how it is, so you can say minimum dimension of the shaft hole is 10, maximum dimension of the shaft is 9.9, means there is always a clearance of 0.1 mm, means 0.1 mm gap is clearance is provided intentionally, that provided is intentionally. So that dimension is called the allowance. Okay, so tolerance means it is different. Tolerance means it is, so that here you can see point 10 plus 0.1 minus 0, means dimension may be 10.1 and maybe 10. So that should be between 10.1 to 10. And allowance is, it will be intentional one. Tolerance is not. So you don't confuse between the tolerance and allowance. Normally in the exam, so they will ask the question, differentiate between allowance and tolerance. So at that time you need to define this and you can give the example. Next is fit. Fit means it is the assembly condition between hole and shaft. It is the relationship between the two meeting parts. So we shall see in detail about this in the next slides about the fit. So you can see these terminologies are explained in the figure. So you can see, so this blue color is shaft and this is hole. So whatever the red color mentioned, it is the tolerance on the shaft, and this is, so whatever the this color, that is tolerance on the hole. So you can see this is the tolerance on the hole and this is the tolerance on the shaft. You can see minimum diameter of the shaft and maximum diameter of the shaft, and this difference between minimum diameter and maximum diameter, it is called the tolerance. That is tolerance of the shaft and maximum diameter of the hole and minimum diameter of the hole, and difference between these two, it is called the tolerance. So again, so this is a basic size. So basic size, so you can see, so this is the lower deviation and this is the upper deviation. So deviation is always defined with respect to the basic size, means it is zero line. So here you can say, so this is upper deviation, so deviation is defined with respect to the zero line and lower deviation. And for the hole, so you can say this is the lower deviation, means yellow color is lower deviation of the hole, and so this is the upper deviation for the hole. So from the figure it will be more clear. So let us see in detail about the tolerance. So first of all, definition is, tolerance definition is, it is the difference between upper limit and lower limit of the dimension. So जो भी lower limit and upper limit के बीच में difference होता है, so that is called the tolerance. So it can also be defined as the permissible variation in dimension. So tolerance are mainly classified into two types: unilateral tolerances and bilateral tolerances. So next is, first of all, why tolerances are specified. Why, otherwise you can say, why we need to provide the tolerances. Because there are many reasons, so why we need to provide the tolerances. First one is variation in properties of material being machined introduce the errors. So because material properties always changes, variation in material properties, properties of material changes with respect to time, because change in temperature, change in environmental conditions, humidity and other parameters. So because of that, so material properties always changes. So that, because of that, we need to provide the tolerance. Next is, the production machines themselves may have inherent accuracies. Means whatever the machines we are going to use to manufacture the parts, so they will not be 100% accurate, because there may be vibrations, there may be some other temperature changes, so there may be some many other reasons. So because of that, so we cannot have the exact machines, so there will be some inaccuracies. So because of this also we need to provide the tolerances. Next is, it is impossible for an operator to make perfect settings. Perfect settings operator को नहीं कर सकता है, operator नहीं कर सकता है, so it's almost impossible. So while setting up tools and workpiece on the machine, so some type of errors may likely to creep in, so errors होता है. So because of this main three reasons, so there are other reasons also, and these are the main reasons. So because of this we always need to provide the tolerances. Means, what is meaning of this is, any part, any given part we cannot manufacture to the exact dimensions. We can manufacture between the two limits. Means suppose देखो कि if there is any part of 10 mm size, so it is not possible to manufacture the that particular part to the 10 mm. Means exactly 10 mm size manufacturing नहीं कर सकते, but it can be manufactured between two limits like 10.1 to 10.2. so इसके बीच में हम मैन्युफैक्चरिंग कर सकते हैं 10.1 to 10.2, but we cannot manufacture the that to the exact 10 mm size. exact 10 mm size को मैन्युफैक्चरिंग नहीं कर सकते. So that is 10.1 to 10.2 means what we have done is we have provided tolerance. So 10.1 is the minimum limit, 10.2 is the maximum limit. So this, like this, we need to provide the tolerances. So next is types of tolerances. First one is unilateral tolerances. So unilateral tolerance means if in this case tolerance is provided only on one side, either side, means either it on the plus side or it on the minus side. So example you can see here. So you can see here tolerance is provided so here you can say 10 plus 0.1 minus 0, means here you can say tolerance is provided only on plus side, means minus plus 0.1 minus 0 means it is plus 0 minus 0 doesn't matters, means tolerance is provided only on the plus side, not on the minus side. Minus side it is 0, and here you can say tolerance is provided only on the minus side, not on the plus side. Means if the tolerance is provided on only one side of the basic size, so then that type of tolerances are called the unilateral tolerances. Either it may be on the plus side or it may be on the minus side. So here you can see, so basic size, so here it is tolerance is provided on the minus side, and here it is tolerance is provided on the plus side. So next is bilateral tolerances. So bilateral tolerance means tolerance is provided on both side of the basic size, means on plus side also, minus side also. So here you can see, so tolerance is provided on plus side also, minus side also. Plus 0.1 minus 0.1, plus or minus 0.1 means it is plus 0.1 minus 0.1. So tolerance is provided both on the both sides of the basic size. So this type of tolerances are called the bilateral tolerances. Next, let us see the fits. So fit means it is the relationship between the two mating parts that are to be assembled. What means it is means the relationship between two mating parts that are to be assembled, that is hole and the shaft, with respect to the difference in their dimensions before assembly, is called the fit. So an ideal fit is required for proper functioning of the mating parts. So there are three basic type of fits. They are clearance fit, interference and transition fit. देखो first of all, fit means it is the relationship between the two mating parts that are to be assembled, that is hole and the shaft, with respect to the difference in their dimensions before assembly is called the fit. So कौन सा भी दो पार्ट आप असेंबली करने वाला है, उस पार्ट का जो डायमेंशंस है बिफोर असेंबली, असेंबली करने से पहले जो भी पार्ट्स का डायमेंशंस होता है, तो उसके हिसाब से वो जो फिटिंग कैसा होता है दोनों के बीच में, टाइट हो रहा है क्या, लूज हो रहा है क्या, सो दैट इज कॉल्ड द फिट. सो डिपेंड अपॉन द लूज हो रहा है क्या, टाइट हो रहा है, सो उसके हिसाब से सो हम दे आर क्लासिफाइड एज द क्लियरेंस फिट, इंटरफेरेंस एंड ट्रांजिशन फिट. सो ये हमारे को व्हाई वी रिक्वायर्ड टू have the proper dimensioning before assembly. So for particular functions, so you require the particular type of fit. एक time loose, sometimes it requires loose fits, sometimes it requires tight fits, so depend upon the functional requirements. So fits are classified into three types. So let us see one by one. Clearance fit. Clearance fit means the largest permissible diameter of the shaft is smaller than the diameter of the smallest hole. Means you can see here. So here you can see this is the hole and this is the shaft. So hole का जो minimum diameter है, so that is, otherwise you can say largest permissible diameter of the shaft. देखो here largest diameter of the shaft is smaller than the diameter of the smallest hole. Diameter of the smallest hole उससे कम है largest diameter of the shaft. So here it is explained with the example of dimensions. So it is the dimension of the hole, it is the dimension of the hole and it is the dimension of the shaft. देखो largest diameter of the shaft is how much it is, 9.9. Smallest diameter of the hole is 10. Means it is largest diameter of the shaft is, that is 9.9, is smaller than the smallest diameter of the hole, that is 9.9 is smaller than 10. Means क्या होता है, so here there is always a some clearance, so that is minimum clearance, there is always a some clearance between the hole and the shaft. So here it is again explained, hole and shaft, so there is a clearance, so there is always a clearance. So this type of fit is called the clearance fit. So next is interference fit. So interference fit means it is minimum permissible diameter of the shaft exceeds the maximum allowable diameter of the hole. So this type of fit always provides the interference. So you can see here. So here you can see. So here always some interference. देखो here it is minimum permissible diameter of this shaft. इसका देखो this is the shaft, minimum permissible diameter of the shaft is exceeds, that is more than the maximum allowable or permissible diameter of the hole. So here it is example, देखो this is the diameter of the dimension of the hole example, and this is the dimension of the shaft. So what is the minimum permissible diameter of the shaft? It is 10.2. And what is the maximum permissible diameter of the hole? It is 10.1. That means minimum permissible diameter of the shaft means it is 10.2 is exceeds the maximum allowable diameter of the hole, that is 10.1. 10.2 is more than 10.1. That means here there is always a some interference. हमेशा क्या होता है, so there is always a some interference, minimum there is a interference, so 1.1 mm का interference always होता है. So where this type of fits are required, where you need to have the tight assemblies. So example, that is bearing bushes, keys and keyways. So next is transition fit. So it is combination of both clearance and interference fit. So in this type of fit, the largest diameter of the hole is greater than the smallest diameter of the shaft, but the smallest diameter of the hole is smaller than the largest diameter of the shaft. So here I will give the example. देखो, in this fit, in this type of fit, largest diameter of the hole is greater than smallest diameter of the shaft. देखो, largest diameter of so this is the, let us take, this is the hole dimensions and this is the shaft dimensions. So in this type of fit, largest diameter of the hole is 10.1. Largest diameter of the hole is greater than the smallest diameter of the shaft. Smallest diameter of the shaft is 9.9. Here it is 10.1 is more than 9.9. But the smallest diameter of the hole is, the smallest diameter of the hole means it is 10 point, smallest diameter of the hole, how much here it is 10. Smallest diameter of the hole is smaller than the largest diameter of the shaft. 10 is smaller than the largest diameter of the shaft means it is 10.1. 10 is smaller than the 10.1. So इसमें क्या होता है, so both are possible. There may be clearance fit also, there may be interference fit also. Suppose if the hole dimension become 10.1 and shaft dimension become 9.9 after manufacturing, so there is a clearance of 0.2 mm between shaft and hole. Suppose if the hole dimension after manufacturing it is 10 mm and shaft dimension is 10.1, then in that case there will be interference of 0.1 mm. Means both cases are possible, clearance fit also possible, interference fit also possible. So this type of fits are called the transition fit. So example, it is coupling rings. So next is, so basis of systems. So basis of systems, so there are two basis of systems. First one is called the hole basis system, so second one is called the shaft basis system. So let us see that shaft basis system in the next slide. First let us see hole basis system. So what is meaning of the hole basis system? So in this system, the basic diameter of the hole is constant while the shaft size is varied according to the type of fit. So here it is figure, it explains. So you can see here, so size of the hole is constant irrespective of the what type of fit you required. So whether it required clearance fit, whether you require transition fit, or whether you require the interference fit, hole dimension is constant and shaft dimension is changed according to the type of fit is required. So this system is preferred to provide the tolerances because so it is easy to change the dimension of the shaft, so rather than the dimension of the hole का dimension अगर कुछ उसमें small changes करने गए तो so it is costlier, so because it is requires a particular drilling process. So again we need to select the proper drill bit, again it will be somewhat costlier as compared to the shaft. So shaft, if you want to change the dimension of the shaft, so it is possible with a simple turning process, so it is possible. So that's why so hole basis system is preferred. Means hole basis system means in this system the basic diameter of the hole is constant while the shaft size is varied according to the type of fit. जो type of fit चाहिए उसके हिसाब से होल का डायमेंशन कांस्टेंट रखता है और शाफ्ट का डायमेंशन चेंज कर देता है। तो इस टाइप का सिस्टम को हम क्या बोलते हैं? होल बेसिस सिस्टम। So next is shaft basis system. So in this system, the basic diameter of the shaft is constant while the hole size is varied according to the type of fit required. So here it is given example. देखो, this is the shaft. So its dimension is constant and hole dimension is changed according to the type of fit required. So here hole dimension is provided. So type of fit here it is clearance fit. Hole dimension is provided here so that it will have the transition fit, and here it is hole dimension is provided so that it can have the interference fit. So this type of fit is normally not preferred. Shaft based system is normally not preferred, but in some cases, some applications, only in few applications, so this type of fit is provided where, so you can see here, so it may be, normally shaft based system is not preferred, but it may however be necessary to use shaft based system where different fits are required along the long shaft. Matlab, so suppose if you want to mount different parts on the same single shaft, so in that case, so this type of fit system is preferred. Example, in case of the driving shafts where single shaft may have to accommodate to variety of accessories such as couplings, bearings, collars, so means you need to fit these things on the single shaft. So in that case, so shaft dimension should be changed, so according to the type of fit required. So in that case, so we should need to use the shaft basis system. Means only in few applications we prefer the shaft based system. So in most of the applications, so we prefer the hole basis systems because of economical. Material conditions. So there are two material conditions: maximum material condition and minimum material condition. So first of all, let us say maximum material conditions. So what is meaning of this maximum material condition? So it means it is the condition where a feature of size contains maximum amount of material within the stated limits of size. It is the maximum limit of the shaft and minimum limit of the hole. Means in simple term, if I explain, देखो, अगर suppose shaft dimension is, so suppose if you say shaft is 10 plus or minus 0.1, so in this case, if the shaft dimension is 10.1, then इसका क्या होता है? So at this condition material required is more, because shaft dimension जितना बढ़ता है उतना material requirement बढ़ जाता है. So maximum dimension is 10.1 and minimum dimension is 9.9. Means it is, so 10.1 is the maximum material condition and 9.9 is the minimum material condition for the shaft. You can see here, so it is the maximum limit of the shaft. What we are discussing is maximum material condition for the shaft. 10.1 is the maximum material condition, and for the hole, होल में देखो, जितना मटेरियल साइज ऑफ होल बढ़ता है उतना मटेरियल कम होता है. क्यों? वाई? सो वी आर गोइंग टू रिमूव द मटेरियल टू इंक्रीज द साइज. So that's why, so suppose if we say hole dimension is 10 plus or minus 0.1, so if the hole dimension is upper limit means 10.1, means then at that time material requirement is minimum. If the size of the hole is means 10 minus 0.1 is 9.9, so for that particular size material requirement is less. मीन्स शाफ्ट में क्या होता है, साइज बढ़ने से मटेरियल बढ़ता है, होल में क्या होता है, साइज बढ़ने से मटेरियल कम होता है. सो बोथ आर टोटली अपोजिट. दैट्स व्हाई maximum material condition means the condition where future size contains maximum amount of material within the stated size. Means it is the maximum limit of the shaft and minimum limit of the hole. मतलब maximum limit of the shaft means maximum limit of the shaft requires maximum amount of material. Minimum limit of the hole required maximum amount of material. So next is minimum material condition, or sometimes it is also called the least material condition. Condition where a feature of size contains least amount of material within the stated limits of size. So it is the maximum limit of the hole and minimum limit of the shaft. मतलब maximum limit hole के लिए minimum material लगता है, requires minimum material, and for minimum size of the minimum limit of the shaft requires minimum material. So these conditions are called the minimum material condition or least material condition. So next is AUTOCOLLIMATOR. So this, so here you can see, so this is the device, so which is called the AUTOCOLLIMATOR. So this is very important from exam point of view. So normally this question will going to ask repeatedly in the exams. So AUTOCOLLIMATOR is used to detect and measure small angular tilts of reflecting surfaces, so placed in front of the objective lens of the AUTOCOLLIMATOR. So here you can see, so I will explain once again. An AUTOCOLLIMATOR is a device which is used to detect and measure small angular tilts. So why it is used? To measure the small angular tilt of reflecting surfaces. Only it is used for reflecting surfaces placed in front of the objective lens of the AUTOCOLLIMATOR. So let us see its principle. So how it is going to work. So here you can see, so this is the surface, that is plane reflector, so of which we want to see the inclination or tilt. So here you can see, so this is a point source, means it is a light source, so it is called the collimating lens, and this is the surface, that is the reflecting surface. So suppose if the reflecting surface is 90° to the lens, so in that case what happens, so whatever the light source rays comes and goes through the collimating lens, and once it is impacted on the this plane, that is reflecting surface, so it will be revert back in the same direction, along the same direction. And so again, that whatever the reflecting back rays, so that will also form the some point source, light source, so that will come at the same point of light source, जिधर से light source जनरेट होता है रिफ्लेक्ट होने के बाद, सो वही आके लाइट सोर्स आता है उसी प्लेस पे. So that is a reflector is at 90° with the direction of rays. But when the reflecting surface is not like this, means it is not 90° to the flowing rays, that is direction of rays. देखो, this is the direction of rays and this is the reflecting surface. So here it is reflecting surface is not 90° to the, that is direction of rays. Reflector is not at right angles to the direction of rays. So in this case what happens, suppose let's see, you can see, so this is the O means it is the light source, so it's generates some light rays, and this is the collimating lens. Once the light rays passes and once it is impacted on the reflecting surface, so here light rays will not revert back along same line, it will follow the different line. So and it will form the reflecting image, so which is not at the light source, it is at the different point, but on the same focal plane, but on the same focal plane. And this distance o and o dash, you can measure it by using scale. And once you measure the scale, so by using this equation, so we can find the angle of tilt, that is theta. So how much angle of tilt is there of this reflecting surface, so with respect to light rays, direction of rays, we can find it. How it is? O dash means it is o dash is distance, so we can measure it with respect to scale, that is x. It is o dash means it is also denoted by x, it is equal to 2f into theta. So here o dash is the distance between o and o dash, so which we can measure with the help of scale, is equal to 2 into f. F means it is the focal length. Focal length is constant for the given collimating lens. For a given collimating lens के लिए focal length f value constant होता है, particular value होता है. And afterwards theta means it is the angle of tilt, so we can measure the angle of theta, that is angle of tilt. So whatever the value of theta we are going to get from this equation, so that will be in radians. So next is grades of tolerances. So grade is a measure of magnitude of the tolerance. Lower the grade, the finer the tolerance. So there are 18 grades, so which are allocated the numbers, that is from IT01, IT0, IT1 to IT16. So fine grades are referred to the by first few numbers. As number gets larger, so the tolerance zone becomes progressively wider. Means, so for every tolerance value, so IT1 means it indicates particular value of tolerance, IT0 indicates particular value of tolerance. Means so values are denoted by some symbols, so they are called the tolerance grades. So here you can see tolerance grades IT5. Some few examples are given here. IT5, IT6, IT7 means it is 7i, 7, 10i, 16i. So this in the, so this tolerance grades are indicates. So suppose if you say, so there is a shaft 10 mm with a tolerance grade of IT5, means IT5 means it is a particular value, it will indicates particular value. IT5 means it is equal to 7i. 7i means, so I we are going to calculate the value, and afterwards so we can multiply it by 7, so we are going to get the whatever the tolerance value. So I value is depends on the different parameters, so that we shall see in the uh, problems, so that is gauge design problems. So in detail, so we shall discuss about these things in the during solving of the gauge design problems. So next is limit gauges. So limit gauges means these are the inspection tools which are used to check the dimensions of the manufactured parts. Means so these are the gauges, gauges are inspection tools, so which are used to check the dimension of the manufactured parts. So manufactured parts का dimension check करने के लिए यूज करता है. These are the tools which are used to check the dimensions of the manufactured parts. So limit gauges ensure the size of the component lies within specified limit. So it is important to understand that limit gauges ensure the size of the component lies within specified limits, but they are non-recording and do not determine the exact size of the part. देखो, suppose I will give the example. Suppose if there is a shaft with a 10 plus or minus 0.1. Upper limit here it is 10.1, lower limit is 9.9. So gauges are used to check whether the dimension is within this limit or not. 10.1 से 9.9 के अंदर है क्या नहीं, वो चेक करने के लिए लिमिट गेजेस को यूज करता है. But limit gauges will not check the exact size. So exact size कितना है means 9.95, 9.96, 10 mm, 10.05. So exact कितना है, so that will not be get it from the limit gauges. It is not possible from the limit gauges. So limit gauges are used only to check the whether the dimension is within that specified limits or not. So that is only we can do with the help of the limit gauges. So I will not go detail about the history of limit gauges. So you can read in my notes given. So I will go to the latest history, so which is important for exam also. So in the 1905, William Taylor explained that concept of relation between two process of checking component, that is checking specific dimension of the component and checking different element of dimension, that is geometric features. Its concepts are known as Taylor's principle, are used in the design of limit gauges. So I'm going to tell you first of all. So before uh, continuing this watching this video, so you just study the GD and T. So that is geometric dimensions and tolerances, so which is in my notes. So you just go through that, then you will understand this properly. देखो, so in 1905 William Taylor explained the concept of relation between two process of checking the component, that is checking specific dimension of the part, checking specific dimension of the component and checking different elements of dimension, that is geometric features. So geometric features means circularity, cylindricity, parallelism, so etc. So simultaneously along with checking the dimension, so we can also check other parameters also, that is geometric features. So his concepts are known as the Taylor's principle, are used in design of limit gauges. So next is Taylor's principle. So it is called the Taylor's principle. So Taylor stated that go gauge should check all possible elements of dimension at a time. You can see, try to understand this statement. So it is very important from exam point of view also. So in the exam normally they will ask the question, state and explain the Taylor's principle. Okay, so Taylor stated that go gauge should check all possible dimension at a time, and no go gauge should check only one element at a time. According to Taylor, go and no go gauges should be designed to check the maximum and minimum materials. देखो go gauge means it is, so I will explain, I will come back again for this Taylor's principle. So after we see the gauges, okay. So first of all, let us see about, next let us see about the gauges, limit gauges. देखो go limit corresponds to maximum material limit. So मैंने पहले एक्सप्लेन किया था मैक्सिमम मटेरियल लिमिट्स और मैक्सिमम मटेरियल कंडीशन एंड मिनिमम मटेरियल कंडीशन. So that already I explained. Okay. So go limit corresponds to the maximum material limit considerations, that is upper limit of the shaft and lower limit of the hole. Maximum material limit means it is upper limit of the shaft and lower limit of the hole. The corresponding gauge is called go gauge. मतलब go gauge is used for the to check the upper limit of the shaft and lower limit of the hole, that is maximum material condition, maximum material limit. No go gauge, no go limit corresponds to the minimum material condition, that is lower limit of the shaft and upper limit of the hole. Corresponding gauge is called the no go gauge. So here if it is not clear till now, so I will explain different gauges first. So you can see, so this is the first one, plug gauge. So it is a plug gauge, so you can see here. So plug gauges are used to check the limits of the hole. Okay, suppose you can see here it is a plug gauge. So when you want to check the hole dimensions within that particular limit or not, to check the, to know the whether the dimension of the hole is whether that particular limit or not. Suppose if I give the example, hole dimension, let us say 10 plus 0.1 minus 0, मतलब मैक्सिमम डायमेंशन कितना होता है 10.1 and minimum dimension is 10. So go gauge means, so when you insert this gauge inside the hole, so this portion should go inside the hole, go, and no go gauge should not go inside the hole. Means suppose समझो कि let us say, suppose if the go gauge this diameter is 10.11. So if it is 10.11, so if the hole dimension is within 10.1, then this will not insert into the hole, because so this is a more than this 10.1. So in this case, dimension of the hole is less than 10.1. And go gauge, suppose let us say if the go gauge dimension is, that is less than 10, that is more than 10, means suppose if it is 10.01, so minimum dimension is 10. So if the go gauge dimension is 10.1, if it is inserts, agar if it goes inside, then that means the dimension is more than 10. And if no go gauge, if it is not inserted into the hole, that means shaft hole dimension is less than 10.1. Means what it indicates is hole dimension is lies between 10 and 10.1. सो इधर क्या हुआ कि प्लग गेज हम यूज करके सो होल का डायमेंशन को इसके लिमिट के अंदर है कि नहीं हमने चेक किया. ओके, सो दैट्स व्हाई सो गेजेस आर यूज्ड टू चेक द लिमिट्स ऑफ द पार्ट्स. It will not be used, it is not used to check the exact dimensions of the parts. Next, same way in opposite way, Means suppose if you want to check the limits of the shaft. So here you can see, so this is the limit of this is the shaft. If you want to check the limit of the shaft, we are going to use the ring gauge. In the previous time, so what we have used is, so it is a plug gauge. Plug gauge is used to check the limits of the hole, and ring gauge is used to check the limit of the shaft. So here you can see these are the ring gauges. So it is used to check the upper limit and it is used to check the lower limit. So here you can see shaft. So this is the ring gauge. So it is no go gauge and it is a go gauge. Means go gauge means, so when you insert this into the shaft, it should insert, it should go, ऐसा पास होना चाहिए shaft के ऊपर से. So that means the shaft size is within that maximum material condition. And if the shaft, if you insert this no go gauge, no go gauge अगर आपने insert करने के लिए try किया, it should not go, ना ही जाना चाहिए. So then it means shaft limit is more than the lower limit. That means it is size of the shaft is within that allowable limits. So in this way, so we can check the whether the dimension of this shaft is within that allowable limit or not. दो लिमिट के बीच में है क्या नहीं, हम गेजेस यूज करके चेक कर सकते हैं. बट गेजेस यूज करके हम एग्जैक्ट डायमेंशन मेजरमेंट नहीं कर सकते. स्नैप और gap gauges. So these are the somewhat different type of gauges. So these type of gauges are used. The snap gauge usually consists of a plate or frame with parallel faced gap of the required dimension. So here you can see, so this is a parallel faced surfaces with some gap in between. So this dimension is equal to the required dimension. So जितना हमारे को डायमेंशन को मेजरमेंट चेक करने के, so that will be equal to dimension of this gap. Gap gauges can be used for both cylindrical as well as non-cylindrical shapes. देखो in previous slides, so we have seen plug and ring gauges. So they are normally preferred for circular shapes. But if the shapes are not circular, if it is like rectangle, square, so in that case, so this snap or gap gauges are used to check the limits. So next is air gauges. So these are the air gauges uses the change in air pressure or flow rates to measure the dimension and to determine the attributes, means other features. So they provide high degree of accuracy in high volume production environments. So इसका air gauges का dimension accuracy is good as compared to other gauges, but these are costlier. Thread gauges. So these are the thread gauges. So these are used to check the limits of the threaded parts. So plug and ring gauges are used for what you can say flat surfaces, means smooth surfaces. So thread gauges are used for the to check the limits of the threaded surfaces. Next is filler gauges. देखो these are the filler gauges are used for in case of the machine assembly or finished product assembly. The distance between two mating parts of some components cannot be measured by conventional measuring instrument like micrometer. अगर डायमेंशंस बहुत छोटा है तो क्या होता है, माइक्रोमीटर, वर्नियर कैलिपर एंड अदर इंस्ट्रूमेंट यूज करके हम उसका डायमेंशन मेजरमेंट नहीं कर सकते. तो इन दैट केस, सो वी विल यूज दिस गैप गेज, सॉरी दैट इज फिलर गेजेस. So filler gauges को by inserting these filler gauges, so you can check the or you can measure the dimensions. So these are called the filler gauges. Specifically these are used for to check to measure the small dimensions. So next is design of limit gauges. So I will just give you the introduction for this. So first of all, we need to know guidelines for design of gauges. First one is the form of go gauges should exactly coincide with the form of mating parts. मीन्स गो गेज का जो फॉर्म है, फॉर्म मीन्स अगर पार्ट सर्कुलर है तो गेज भी सर्कुलर होना चाहिए. सो दैट इज कॉल्ड द फॉर्म. गो गेजेस शुड एनेबल साइमल्टेनियस चेकिंग ऑफ सेवरल डायमेंशंस. गो गेज को कैसे चेक करते हैं? गो गेजेस विल इंसर्ट इनटू द पार्ट्स. पार्ट के ऊपर इंसर्ट हो जाता है गो. सो उसके उसके लिए क्या होना चाहिए? सो बिकॉज ऑफ दैट गो गेजेस अलॉन्ग विथ size, it should also check some other parameters like other geometrical parameters, that is circularity, cylindricity, some other features. No go gauges should enable checking of only one dimension at a time. So no go gauges will check only one thing, that is that is minimum material condition, because it will not insert into the part. अगर insert नहीं हुआ तो other features को हम check नहीं कर सकते. That's why no go gauges should enable checking of only one dimension at a time. Design of limit gauges. Again, in this again material consideration of gauges for gauges. So materials consideration is also very important. Means which materials we can use for manufacturing of gauges. First one is gauges are inspection tools requiring high degree of wear resistance. Means बार बार क्या होता है कि gauges you need to insert into the parts. So because of that, so there is the wear. So that's why whatever the material you are going to use to manufacture the gauges, so they should have the high wear resistance. Apart from this, gauge also required to ensure the stability of size and shape and corrosion resistance. They should have the low temperature coefficient, means टेम्परेचर चेंज होने से उसका डायमेंशन चेंज नहीं होना चाहिए. सो नहीं तो क्या होता है? सो इंस्पेक्शन में एरर हो जाता है. So this is also important. Next is gauge tolerance. So gauges को भी what we need to do is gauges also like other jobs required to manufacturing tolerance. क्योंकि इसको भी मैन्युफैक्चरिंग करना पड़ता है, गेज को भी मैन्युफैक्चरिंग करना पड़ता है. So if you want to manufacture, you should provide the tolerances, because you cannot manufacture any part to the exact dimensions. The gauge tolerance should be kept minimum as possible, though it involves a high costs. Though high costs are involved to do so. Means if you keep the minimum tolerance, so it in manufacturing cost will be high. But you should keep the minimum tolerances. The tolerance on the go and no go gauges is usually 10% of work tolerance. जो जो ऑब्जेक्ट को इंस्पेक्शन करने के उसके ऊपर जो टॉलरेंस रहता है, दैट इज कॉल्ड वर्किंग टॉलरेंस. सो उसका 10% टॉलरेंस विल बी प्रोवाइडेड ऑन द gauges. So next is wear allowance. So go gauges are subjected to wear due to the rubbing against the part during inspection, and hence a provision has to be made for wear allowance. Means go gauges are inserted on the parts, into the parts or on the parts. Because of that there will be a rubbing action between the gauge and the part. So because of that there will be wear. So उसका लाइफ अगर बढ़ने का है, if you want to more life for the gauges, so you need to provide the we need to provide the wear allowance. So we shall see these details while solving the problem on gauge designs. So wear allowance is taken as 10% of the gauge tolerance. So whatever the gauge design of limit gauges, whatever we have seen introduction, so we shall see again in detail while solving the problems on the gauge design. So I hope you have understood some whatever I explained. So if you have any doubts, so you can contact me. Thank you for watching this video. See you in the next video.